Well, my name is Mario Klingemann. I don't know if that's still important. Well, it's actually written somewhere, right? So, well, I am an artist now. I mean, I haven't always been an artist, or I haven't dared to call myself an artist for a long time. But since several years, I decided, yes, actually what I'm doing as an artist is to be an artist. And, well, I'm working with computers and data algorithms and try to make the machine help me create interesting images, sound, anything. So it tries to generate for me interesting information, things that are novel, that are entertaining, that are different. In the past 2 years, I kind of deeply entered the field of artificial intelligence, or I don't know if we can already call it like that, but deep learning. And now I'm really trying to train machines to be almost autonomous in their way of generating new content. And some of it is hopefully art. So, well, I guess we get to the details later. But yeah, in the end, I managed to have the machine produce me something, and I look at it and decide if it's already interesting enough, or if I have to tweak some more on those knobs and in the code. Maybe you want to hear something about my background too, because there's no real background. So I neither went to an art school, nor did I study information technology or computer science. I'm entirely self-taught, but I started many years ago, like, I don't know, when I was 12 or 13, I had my first computer, and then decided that this is very fascinating and allows me to, well, generate new things, make new things, but at the same time I only have partly control about it by initially entering randomness or, well, certain quirks into the algorithms. The machine allows me, like, it's kind of this other entity where I put something in, but the output I get is not always what I expect or is surprising. And so that kind of principle has fascinated me, and so I, well, tried to, well, in a way I always wanted then to do something with computers and visuals, or, well, mostly visuals. But when I was done with school, that was by the end of the 90s, that field was, I mean, it did exist probably somewhere, but there was no internet yet, so I didn't know where to look for. And definitely art school was not the way to go, because that had required me to learn, like, to actually paint analog, and I have no talent at all to move a brush or something. And that is probably why I like computers so much, because I'm a control freak and I'm a perfectionist in some way, and so taking a brush and trying to make it do something that I have in my head, and I don't manage to do that. So I didn't have the patience to kind of train that. But with computers, I have the way to, well, turn my ideas into something that I can look at. And so at the same time, back then, informatics or studying computers in depth was also didn't sound creative enough. So I always wanted to be creative, I mean, whatever that means. But so neither of those two things did do what I wanted to do. And so I just started kind of, was looking around, oh, where can I be creative? And so then I went actually into advertising. So, because at that time I thought, oh yeah, that's where the creative people are, where I can be creative. And well, it was great, because I met really great people there and I learned something, but over time I realized, well, it's not really what I want to do. So I don't know if I should tell you my entire life story, but so at some point I actually found a way to combine taking a computer and creating visuals, and that was techno. That was kind of the mid-90s, where techno came up in Germany, and people needed flyers and posters, and they should look as kind of crazy as possible. And so that was a great field where I could start kind of doing my thing, because I started writing my own visual effects, because of course there was Photoshop or so, which had just a few ones, and I wanted different ones. So kind of that was the beginning of where I did generative art, I would say. I mean, at that point, that term didn't exist, so I didn't know that I was doing generative art. I was writing code which produced images, and I added sliders, so the images changed and in interesting ways. So looking back, and that was how many years? Over 20 years, 30 years almost. So I think that is kind of, I would call that generative art, but well, that term only came up 10 years later. And so I evolved with technology, so new things came up, the internet, computers became more powerful, new techniques came up, and so over time I could do more and more go more and more in the direction that I wanted to. And well, I always thought actually this stuff is artistic, but since I didn't go to art school, I didn't know how do you become an artist. So one thing I also am fascinated with is systems of any kind. So in a way you could say you look at something, even like a watch, and you wonder like, what makes this tick? How does it work? Like how do those parts fit together? But at the same time you can look at, I don't know, you can look at society. How does religion work? How does the art world work? So, and I try to kind of make up my own mind, like what are the players, what makes a piece on the wall an art, which is let's say, which is considered to be art and not just something like a nerd did by hacking some code, or just some kid drawing on a... So I made up my own ideas, and also of course my plans how I could enter that field without having some of those typical prerequisites that you have, because yes, there are typically, yes, if you want to be an artist, you go to art school, and then you become an artist. If you come from the outside, you are an outsider already, so you have to find other ways to get kind of acknowledged that what you're doing could still be considered art. So, and obviously it's about attention and actually getting visible. So, well, on multiple fronts, I kind of started by working my way in. And, well, one thing I realized is, yes, you can do as much as you want, nerd, generative art. As long as you don't call yourself an artist, you are just some kind of nerd scientist who does beautiful pictures. And with getting more people, getting to know more people and learning about this, I decided, yes, well, one of the actually prerequisites is that you have to say, yes, I'm an artist, and what I'm doing is not just kind of playing around in eye candy. And so, well, I'm a late bloomer, I could say, but right now I'm pretty confident about this, that especially if you look around what else is done, I think I'm currently in a good spot where interesting things are happening, which kind of bringing new things to the table. What I'm doing, okay, let's say on the basics, I'm using computers to make art. And people have been using computers to make art since computers were available, in the 1960s. They were already the pioneers. So that field you could call generative art, or also permutative art, because of course one of the core things that a computer allows you is to generate hundred thousands of variations of around a certain theme within a very short time. On the other hand, what I'm doing right now, making art using neural networks is relatively new, because especially if you go for visual art, I mean, there are people, actually I found this book which was from the 1980s, where people were already kind of talking about it, that this might become possible, but technologically, in a way, it's only possible since a few years, like otherwise it would just be small. So so in the wild field, yes, we are in generative art, but on the other hand, well, okay, so I have a term for what I'm doing, and I call it neurography, which is, I mean, the term already exists in medicine, but I try to give it a new meaning. And neurography is kind of like photography in the latent space that neural networks generate. Oh, lots of, but yeah, so in a way, like if you take a look at photography and have a photographer, well, the photographer takes a camera, goes out in the world or in a studio, and then frames it, and then says, okay, I take this looks good, or this looks interesting, this looks like something I want to express. And so what I'm doing is I'm generating a kind of a virtual abstract world by training a neural network, and then I can go inside there. Well, maybe I explain that a little bit in detail how going inside looks, but you can almost imagine it's like a space, and you move around, and then you can take pictures in there, and then you can say, oh, this area looks promising, and then you look around in that area and you find more interesting like framings of this, or you change the space, and that's of course how it's different from the world, that I can shape the entire world and make it something different, or merge two worlds, or so there's a lot of more flexibility than in the real world in finding interesting visual spaces. I definitely see I find relationships to surrealism in a way, especially the way the surrealists work. It's, again, the way I work is like if you have something like a frottage, or something that Max Ernst did, where he rubbed a pencil over a piece of bark, and then an interesting shape started to develop, and then you start, well, your brain makes associations, sees something in that shape, and then you go on and keep on developing that. And in the way, the neural networks start giving me shapes, and then I discover something where my brain clicks and says, oh yes, looks like a face, or this looks like a tree, or this looks like something I've never seen, but I find it very interesting. And then I can take this and elaborate or go deeper into it and try, or I just crop it and say that's it. But so that's one thing. Well, I don't know. That's the thing. I don't think so much about the theory. I just enjoy the ride. Okay, a neural network, I mean, the term is even kind of not really true. So in a way, it tries to mimic the way neurons are connected in a human brain. So you have neurons which are connected to other neurons, and they fire, and several neurons are connected to another one, and if enough of them fire, this starts firing and passes on the information. So that's kind of the basic structure. It really doesn't work like the human brain, but it's a simple model which works. So there are lots of different architectures for these neural networks. So when we are, let's limit it to images, because in the past 3 or 4 years there was lots of progress there. Mainly these neural networks were built to classify images, find objects in images. So how it works is, well, it's multiple layers, and in the first layer you pass in the image. So every pixel of the image you could say, is one neuron. And now what happens is these neurons get convoluted. Well, in a way, there are multiple of these ways how they can be connected to each other and then passed on to the next layer. And well, and then it gets passed on to another layer, and every time it gets passed on, it kind of, the information gets condensed a bit more. And what happens is initially, and that's how the human eye works, or the human perceptual system works. So initially it looks at superficial features, say edges, certain types of texture, gradients. So, and whenever it discovers, for example, an edge, certain neurons fire up and say, oh yes, we see an edge. But others say, oh, I see a smooth gradient. That could be like, well, at that point they don't say that could be skin, but let's say the others say, oh, here's no edge, but something that is a smooth surface. In the next layer, there are other neurons that say, oh, I see like three edges in a row, so that might be a line. So then they start detecting structures already in those detected features. The deeper you go, the more these structures that get found get combined, and then maybe certain lines become circles, and deeper circles become something like, could be an eye or a button or something. So, and the way the model learns to know what to look for is by that you train it. And training a model is pretty much like you collect a lot of images that have information you're interested in. That's, well, I always like to take the simple example. You want to distinguish cats from dogs. So what you do is you have 50,000 dog images and 50,000 cat images. And well, all you do is you give the model the image and say, this is a dog, and this next image is a cat, and then again a dog and a cat. And while you're training it, it starts learning which features in an image are important, like distinguish a dog from a cat, because they both have fur, they have eyes, but well, through some way it learns maybe that cat eyes have a different shape, or the fur on the deepest layer has a different structure. And so what really happens is the model takes the, let's say, 100,000 pixels, which in this XY grid, and transform these into this latent space. And that we are back at that latent space. So in a way, it's really, you could imagine initially all these, you are in a multidimensional space, which is, for example, well, it's every coordinate of a pixel and its RGB values. So every pixel has 5, like a X, Y, Z, UV, like 5 dimensions. And in the end, well, the model transforms all these pixels into a multidimensional space. So let's say 128 dimensions. So what happens is every dog and every cat in this space will take on a certain position. And if the model does it right, that it's able to kind of place these images in a way that it can then put something like something in between, say, like a plane in a way, but it's not really a plane, but it's easier to think that way, and say, okay, anything that is on the left side of this plane is dogs, and anything on the right is cats. So, and that's what the model practically does. It tries to sort this space, find the right transformation of any incoming images, so in the end, things that you are interested in to differentiate from each other can be, with relative high probability, be separated from each other. Well, okay, so that's the latent space, and that's training. So in the end, really, you give the model a lot of images, and then you run it for days, and in the end, it gets better and better in distinguishing them. Sorry, I was just talking about classifying. So there are other architectures, because yes, I'm obviously not classifying. I mean, I might be classifying to generate training sets, but generating is using other neural architectures, which is, for example, like very popular, and what I use a lot are so-called GANs, or Generative Adversarial Neural Networks, and they are a very interesting kind of technique, because in the end you have two neural networks. One is a generator, and you can imagine the generator pretty much almost like the classifier. So the classifier, you could say, is like a triangular structure. So you have lots of image data at the top, or well, there's always top and bottom. Anyway, we say the top, and in the end you get an information saying yes or no, or dog or cat. So it's like a triangle. What a generator does, it adds another triangle at the bottom, like a hourglass, and say, so once I have boiled it down to something like a very basic feature vector, learn how to regenerate that image by doing the opposite what you did before. So building the image back from very little information you've got. So really, you put in an image at the top, it gets condensed to its kind of core information, and then the model learns what it has to do to generate that image back. So that is the generator, and if you train it enough, it will do a good job. But in order for the generator to do this job properly, it has to have a discriminator, which is kind of like a judge that watches what the generator is doing, and tells it in a way, you did a good job, this looks almost like the original image, or no, you made a mistake. So both of these models start kind of knowing nothing. So they are really bad. But whilst they are doing both, whilst they are in this cycle where the generator tries to generate an image, passes it on to the discriminator, which looks at it and says, well, yes, this looks good. Well, then probably, sorry, I forgot to mention something. The discriminator also gets the real image too sometimes. So it doesn't know if it's looking at a real image or a fake image. So the discriminator can also make mistakes in saying, oh, this looks good, but it's actually a fake. So when the discriminator makes a mistake, it learns. So it also tries to get better in distinguishing real images from fake images. And at the same time, the generator also learns, like when it's done something bad, the discriminator tells it. So both of them get better and better over time. And that way, yes, they actually can start learning to generate images that trick our eyes and look like real images, or whatever you want them to learn. That's the interesting part. So if I wanted to generate dogs, I could try to generate dogs, but of course I'm not interested in dogs. One of the biggest parts, or the most interesting parts in this whole process is that these models are not perfect. So they never reproduce what you teach it to perfectly, because that would be boring. Yes, I don't want to generate just images that exist. So the interesting thing for me is of course the mistakes the model makes, or the abstractions it does, the shortcuts it takes, and the images that come out then have this uncanny nature. And so that is why I'm so fascinated by it. Regarding the material, well, in a way I can train it on anything. So that is, again, the other... For me, that's kind of like going out in nature and seeing something like a beautiful landscape, or I see people and with an interesting face. So just like any other artist, it's well, maybe depending on your mood or what you want to express. So for me right now, I'm very interested in the human shape, human form. So I'm training a lot of faces and bodies, because this whole field of human perception, how we perceive images, is really what fascinates me. Again, like we start seeing things, making associations, and for example, with the human shape, human form, there is a lot of associations we can make. And well, I can easily go abstract, and I did that initially, because usually the default, if you take an untrained neural network, is already something that looks like abstract art. It's not noise. It already has weird shapes or things that remind you of something. But so abstract is actually the most easiest form of working with neural networks. So I'm more interested in finding this space in between. But I also train it on other things, like pretty much I I'm a big fan of decay and structures and interesting textures. So again, almost like Max Ernst rubbing through tree bark or so. I'm looking for interesting structures. So for example, I train it on electron microscope imagery or destroyed photography. So the whole part of the training is actually a very important part of this whole process, because I can pick something, I can pick any kind of topic or just random images, train the model, and then see how has it interpreted the material, and do I like where it's going, or do I have to change the data? Do I have to add more, take something away? So I always like the kind of this analogy that it's like I'm building a musical instrument, and well, you have lots of materials, and then you pluck a string or you beat it and it makes a certain sound. So in a way, I'm building me these creative instruments, and then while I'm doing it and working with it, I figure out what kind of factors influence the result. So are the images that I have fed in too noisy? Are they do they have too much entropy? So you get a kind of a feeling for what kind of images work. But in the end, really, the whole world, I can use anything, and anything will produce a different output. And I have all these, well, I have lots of models now for different purposes, and then I can mix them or join them in a row. So it's really like, I would say, like artists that work with brushes or like real materials, they also see, oh, this brush gives me kind of this type of stroke, or behaves with this type of ink that way. And in the same way, for me, the data is that this combination of pigment and brush and paper structure. So all these things that influence the final result is, in my case, the data. And the model architecture, that's the other thing.